Hi everyone, this is Mrs. Baxter, and today we are starting a new unit on reviewing quadratic equations. And this is something that we did in intermediate algebra. If you came from a different school, it might have been part of your Algebra 1 or Algebra 2 class. But anyway, so today what we're going to study is quadratics. And hopefully this looks familiar for you, and this is a review, but we'll do this video in two parts. So this first part is just going to be like the first 2 pages, and then the next video you will see the last page on there. Okay, so what is a quadratic? Well, a quadratic is an equation with an x squared term. Okay, so let's see here. So with an x squared, ooh, I don't like that color. I want yellow. With an x squared term, okay? When you see this little 2 right here, under here, that tells you, ooh, I'm going to get 2 answers. We just came out of factoring and solving by factoring, and what we did was we found 2 values for x, and I'll show you what that actually means here when we look at the graph, okay? So the first thing that we're going to be looking at is we are going to be, for the next few days, working with what we call standard form. Whoops, standard form, okay? This is an equation, or the type of equation that means the exact same thing as what you see below. So vertex form, you know factored form because we've been using factored form, okay? But it's just different names for different ways that we can see this equation, or this type of equation that has an x squared term in it. And when we are looking at anything with an x squared, it means we're going to find 2 answers for x, but it also means that we cross the x-axis twice. Okay? So we cross the x-axis twice. Now, you are used to seeing y equals mx plus b, right? So y equals mx plus b. Well, what is this? It's a line, right? And the line only crosses 1 time. All right, in this instance, we're going to cross it 2 times. So when we're looking at the quadratic formula, or I'm sorry, the quadratic right here, y equals ax squared plus bx plus c, what this means is a is a number, x is a variable, b is a number, and c is a number, okay? A, b, and c, it's important to identify what those are when we're looking at quadratic equations and when we're looking at this information for today, okay? Every single thing in this equation means something important, and we'll review what that is here in just a minute. Okay, now below it, you're going to see vertex form, which we will review how to graph that as well here in a little bit. But for today, we are focused on standard form. Okay, factored form, all that is if I were to multiply all of those out and do the distributive property in factored form, it would get me the standard form. So we have various equations and things that are going to help us get from one form to the other. All right, so the graph makes a U shape. This is what we call a parabola. So hopefully this word is kind of a review. So parabola is the same thing as a quadratic. A parabola is the shape that comes out of a quadratic equation. All right, so let's look at the parts of a quadratic. So without looking at the equation itself, let's just identify the parts. So the first part that's important is looking at the axis of symmetry. Okay, the axis of symmetry is an axis, okay, it's a line, all right, and it always is going to be x equals, it's always going to say, sorry guys, it's always going to say x equals some number, okay, and in this case, I'm looking at it and I'm saying, oh, well, x equals, it's going right down here like this, okay, and x equals, here's 0. If I go over 1 point, x equals 1. Okay, so x is equal to 1 in this instance. All right, well, the other important piece is knowing what the vertex is right here. So vertex is where you are going to have your axis of symmetry is going to go right through the middle of it. Okay, and if I were to fold this parabola in half on the axis of symmetry, kind of like on a piece of paper. Imagine I could just take it. The one side of this parabola would be the exact same size and shape as the other side of the parabola. Okay, that's what makes it symmetrical. All right, and then if you remember the y-intercept right here, this is where the parabola crosses the y-axis. Okay, so we have our axis of symmetry. That's the axis that goes through the vertex. Okay, but then also we have our y-axis and we have our x-axis here, which are these two very dark lines that tell us where to start on our grid. Okay, so in this instance, our y-intercept, actually I'm going to make this a little bit thicker, our y-intercept can be found at the coordinates 0, so always remember that we start at 0 on our x, and then we're going to go down 1, 2, -3. 0, -3 is our y-intercept. Our vertex, let's identify that. Our vertex is at, we start at 0 and we go 1, so +1, comma, and then I'm going to go down. If I got +1, then I'm going to go down 1, 2, 3, 4. And that's a -4. That's where our vertex is, okay? And then last but certainly not least are our x-intercept solutions. So this is where our parabola crosses the x-axis. Now, it can do one of several things. So here's one, here's the other axis, okay? So when we're looking at those, I'm going to do our solutions here. The first one is at -1, 0, because we're not going up or down on the y-axis. The second one is, here, let's figure it out. We're going to go 1, 2, 3. So 3, comma, and then we're not going up or down at all, 3, 0. Just like when we did lines, you have an x-axis, you have a y-axis, y-intercept and an x-intercept, sorry. And if you're looking for x, you're going to have a number for x, and 0 will always be your y. But for your y-intercept, it's going to be flip-flopped, 0 for x, and then you're going to have a number for your y-intercept, okay? So being able to identify what I'm saying when I say x-intercept, you know where to look. You're looking on the x-axis. Where does it cross? Okay, y-intercept. I'm looking, where does this cross the y-axis? Vertex, well, that's going to tell me the very top or the very bottom of the parabola. And the axis of symmetry, where it cuts the parabola in half and it crosses through the vertex. All right, so let's try to identify these parts right here in this graph, okay? As I look for the vertex, we're going to look for that first. Right here, let's look for the vertex. The vertex is at the topmost point here. And so at this point, I'm going to look at here and I'm going to go, okay, I start at my 0 and I'm going to count 1, 2 in my x direction. Okay, and then I'm going to count 1, 2, 3, +4 in the y direction. Okay, that's my vertex. Let's look for my y-intercept. My y-intercept is right here. Okay, my y-intercept, and that is at 0, 0. We start right here in the middle. Okay, so this one is going to be 0, 0. My x-intercepts, let's do that. Ooh, look, I've got x, nope, I wanted to highlight that, sorry. X-intercepts, or also known as solutions, are right here. Look, this counts for two different ones, right? So my x-intercepts we know are 0, 0, and 4, 0. So do you see where there's 4, 0? Yep, right there. All right, and then my axis of symmetry, my axis, oops, I wanted to do a different color, sorry. My axis of symmetry is this line that goes straight through the vertex, like that. And in this instance, we say, x is equal to 2. Okay. Now I want you to notice this right here is the exact same as this right here because they're going through the same point. Okay. So please notice that. Okay. Let's look at page 2. Your quadratics right here, graphing quadratics from standard form. Now, don't get scared by this, but I will tell you, this is your cheat sheet right here. Mrs. Baxter is setting you up for success. You only have to follow this graph, okay? I'm going to have you make a couple notes on here, but do not lose this because this is going to help you. All right, so the very first thing that we want to look at is this right here, f of x. Again, don't let that scare you because it's the same thing as y. Y equals, or f of x equals, this equation right here, which is ax squared plus bx plus c. And as you guys know, a, b, and c are all numbers, okay? X squared stays there, x stays there. Remember, this is standard form. I kind of have been talking about standard form for a while now. The first thing every single time that you start working on trying to solve what this parabola is going to look like or where these points are is the axis of symmetry. So you're going to say, put yourself a little note right here like a big star and just say, start here, okay? And this just kind of gives you an idea of like, oh, you're starting here, and then you're going to work down to the bottom. Now, keep in mind, when I give you a worksheet, they may not put them in this order. So pay attention to what the questions are asking you or what the blank spaces are asking you, because sometimes it might ask you a different part of this graph or this little graphic organizer. It might start somewhere else, and that's okay because you always know you need to start with the axis of symmetry, AOS, x equals something. Now, notice when I'm looking at this equation here, x equals opposite b over 2a. Now, the reason why I say opposite b is because if this right here is a negative, you're going to put the opposite right here. Okay, so pay attention to that sign. All right, so if that's a negative, you're going to switch it to a positive. If that's a positive, you're going to switch it to a negative. That's why I like to say opposite b over 2 times a. So a is here, okay? B is here, okay? We don't use c for this one. So you're just going to plug those numbers in, and that's your x. All right. Now, to find the vertex, here's the part that I want you to notice. All right, I'm going to take those out. What I want you to notice is that even though this looks like a big gobbledygook of information, it really makes sense because all they're saying is once you find the answer to this x, once you find the answer to this x, all you're going to do is plug that number into the x in your vertex. Okay, just like I did here. Look, axis of symmetry equals 2. I plugged it in right here. It's the same, all right? So all you're going to do is plug that into your vertex. And then what this f of this equation equals is just saying I'm going to plug in my x back into my original equation. So I want you to draw a little arrow, and you're going to take this, and you're going to plug it back into the equation. So plug x in and solve for your y. Okay? That's all that's saying. So your vertex is still going to be an xy coordinate, but now we've just put it in terms of an equation for you. Okay? So make sure that you know that step 1, you're going to solve for your axis of symmetry. Then you're going to come down here. You're going to put that number into your x spot for your vertex. Then you're going to take that number, plug in x into both of these. Okay, you're going to do both, not just the one, and solve for y. Now, your y-intercept, where your parabola crosses your y-axis, is always the same format, 0, comma, c. So whatever your c value is, you're going to plug that in right there. And the reason why is if you plug in 0 for x, you get c. Okay, you don't necessarily have to write this down, but here's the deal. You're going to use this when we use the other forms. So if you understand that when you plug in 0, you're going to get c, because look at our y-intercept. Where is our y-intercept? It is on 0, comma 0 here, right? Here it is on 0, comma negative 3. What do you notice? Our x is 0, okay? Our x is 0, always, always. Our y might be a different number, but our x is always 0. So if x is 0, we plug it in and find that c is going to be our y-intercept. And you guys will see this in practice. We'll get lots of practice with this, okay? So don't worry. Just make sure you have these notes. Last but not least is maximum or minimum. Is your parabola a maximum or a minimum? Is it going up or down? Okay, so if A is positive and it opens up, you're going to have a minimum. The vertex, this is where the vertex is. So if you need to write yourself a note, vertex. If A is negative and it opens down, you're going to have a maximum. Okay? So I've kind of done a little cheat sheet here over here to this part right here. So if it's going down, you have a max. If it's going up, your vertex is at the minimum point, okay? All right, so let's look at an example, okay? While I'm doing this, you guys use your top form up here. Use this while I'm looking at this example here, okay? And then that way it'll make a little bit more sense. Okay. I just want to make sure I'm zoomed in so that you can see this, but you'll have to refer to your own notes, please, okay? So here we're going to find all that information using this equation here now. Well, that's not quite what I'm going to do, but here you go. Here, we're using this equation here. All right, I'm going to do something a little bit different. My question to you, I'm going to start at the bottom here. Is this a maximum or minimum? Am I going up or down? Well, let's look at our A value, okay? Look at the A value. Well, the first thing I like to do is I like to go, oh, not that. I like to go I didn't want that color either. A is equal to, what number is A? What's that number right there? If you said 1, you'd be correct. B is equal to 6. C is equal to 8. So when you're doing this, write down what your A, B, and C are. If for some reason there was nothing in that spot, like say, I'm going to do something, don't do this. I'm just going to do it for demonstration purposes. If you only had x squared plus 8, B would equal 0. Okay, if there's nothing there, that number equals 0. Okay. Otherwise, it equals 1. All right, so let's look at that. So if I'm looking at A is a positive 1. So positive means it's going to open up. If it opens in the up direction, where's my vertex? It's at the minimum point, okay? So you can solve that without doing any math at all. Just look at your A value. Is it positive? Going up. If it's negative, it's going down. Okay, if you need to draw yourself a little picture like I did. All right, now let's look at our axis of symmetry. X equals opposite B over 2A. Well, I'm going to plug in my numbers. B is 6. The opposite of B is negative 6, right? So I'm looking at opposite B over 2 times, well, my A is 1. So if I solve this, negative 6 divided by 2 really is negative 3. Okay, so x is equal to negative 3. Ta-da! All done. Now, Let's solve for my vertex. Well, remember what I said about plugging in a number. So if we look up here, right here, and I just said, oh, once you find x, plug it into this value here. That's all you're doing. Okay, so now all I'm going to do is I'm going to take my -3 here. X is -3. It's -3, y'all. It's nice and easy. X is -3. Done. But now I'm going to have to plug in x into my original equation. So let me do that. So in order for me to find my equation, I'm going to go, -3. Let me see. Instead of x squared, I'm writing -3 squared, okay, plus 6 times, what's x? -3 plus 8. Okay, I'm going to solve this problem. 9 minus 18 plus 8, y, these are all y is equal to -1. So since y is -1, right there, that is my vertex. Okay, this is my vertex. Cool. Now to find my y-intercept, this is super easy, you guys. Remember, it's 0, c, right? Y-intercept, 0, c. So if we look at my problem, I just go, oh, my y-intercept is 0, 8. All done. All right? Okay, so this is part 1 of solving different pieces of a quadratic equation in standard form. Go ahead, and when you get the homework assignment, it is going to have a graph on it, but I haven't taught you how to do that yet. That is part 2. So I just want you to find this information mathematically first. You have to show your work. If you do not show your work, then you don't get full credit. So anyway, use this chart like your life depends on it. All right. If you have any questions, let me know. I'm happy to help.